So we're going to talk about ASP.NET MVC Solution Best Practices, or as a subtitle, the solution to the solution problem. My name is Steve Smith. You can find me online at ardallas.com or on Twitter with the same name. And here's a little bit about me. I have a About Me slide that you can go check out if you want. I've been working with ASP.NET, ASP.NET MVC since before either one was released, and I've been involved as a developer or reviewer on many different projects built with these technologies, so I want to share some of the things I've learned in this session today. So real quick, the problem that I want to discuss is best represented by this image. If you're a Visual Studio user like myself, you've probably at one time or another created a blank solution, and if you go and you look in the set of templates you can get when you start up a new project, you'll see there's a distinct lack of any kind of guidance from Microsoft on how you should build a solution. And so, there's 3.2 trillion different project templates and one solution template. So the problem with this is that there's a great deal of variation in the way different individuals, teams, and organizations all choose to approach this problem. In some cases, the choices that are made at your solution level can have a very significant impact on the maintainability of the resulting application and its structure. So this is not just an ASP.NET or a MVC concern strictly, but it is one that we're going to take a look at today in the context of ASP.NET MVC4. So there's a couple of different ways that you can experience pain with the way your solution is organized. The first one is that you simply have too many projects. And so when you have too many projects, some of the pain that you'll feel are going to be slower build times, slower load times, different add-ins that do code analysis will take longer. Some of the built-in Visual Studio tools will take longer, and you'll start to have performance issues with the tool depending on your hardware. And you can also have difficulty just finding where the actual code relevant to the issue that you're dealing with is located. I've seen organizations that have 10 years worth and dozens of separate applications, from websites to web projects to console apps to WinForms apps, all in the same solution like the one shown here at the right. The result is a solution with almost 100 projects that if you ever do accidentally hit build, you just better go get a cup of coffee because Visual Studio isn't coming back anytime soon. Related problem is if you have too few projects. And when you have too few projects, the issue there is that frequently there's not enough separation of concerns. And so typically the result of this is that you have a lot more coupling, and you end up with a code base that's more likely to exhibit the big ball of mud or spaghetti code style of architecture or coding. Very frequently there's little, if any, abstraction in a single project solution. So for those solutions that do make use of multiple projects, another problem is sometimes there, and that's that these lack the correct type of abstraction. And so we'll look at an example of this in just a moment. But even if you are breaking out your solution into different layers or projects, you may run into this where you end up with a tightly coupled solution because of the manner in which you chose to split out your projects. So then the ideal, or what I like to call the Goldilocks solution, is one that has not too many and not too few, but just the right number of projects. And those projects have their responsibilities well defined so that your ending solution, your ending application is very maintainable. Now there are a number of principles that I want to talk about that you can keep in mind when you consider how to organize the projects within your solution. Some of these I hope are already familiar to you, some of them may not be. Many of these can be found in more detail in the book Agile Principles, Patterns, and Practices in C# by Robert C. Uncle Bob Martin. Now, it's important to remember that projects are not simply high-level folders for organizing your code, but they also correspond to deliverables in the form of .NET assemblies. So in larger software systems, if your solution is well composed and your application is well composed into different units of deployment, it should be possible for you to deploy a bug fix or to add features by replacing only those component DLLs that have changed without having to redeploy the entire application. This reduces the impact of the change on the system, as well as the likelihood that bugs are going to be introduced by that change. So if we look at these one by one, the first one is the common closure principle. And this basically states that the classes in a component or in an assembly or a project should be closed together against the same kinds of changes. If you're familiar with the open-closed principle, we're talking about closed to change, meaning that you don't have to open up the file and edit the code in order to make changes to it. A change that affects one component affects all the other classes that component in that component and doesn't affect other components is the ideal. So if we have to change the code in an application, we'd prefer that that change occur in a single assembly rather than having to touch multiple different assemblies. And so this principle suggests that if two classes are tightly bound together, either physically or logically, then they are likely to change together, and thus they should belong to the same component. The next principle is sort of related to this. It's the common reuse principle, and it simply says that classes tend to collaborate with other classes, and it makes sense to package those classes together if they frequently work with other classes or always must work with other classes. So those things should belong in the same project. Now the next principle is the stable dependencies principle. And so when we talk about dependencies, we're talking about references that a class has on other classes or other projects. So a module or a class that you have designed to be easy to change can suddenly be made difficult to change by someone else hanging a dependency on it from a hard-to-change component. At that point, anytime you make a change, the code that depends on your code must also be updated, and your easy-to-change class or module just got harder. So when we talk about this notion of stability, we can define it, and we can basically define stability as saying that if a class or a component has many incoming dependencies, many things refer to it, then it is more stable because it requires a great deal of work to reconcile any changes among all the dependent components. We can measure stability in terms of the number of inbound and outbound dependencies a class or a component has. These are also known as afferent and efferent couplings, and you can use tools like nitric or ndepend to measure these on your system. Now, some software in the system should not change very often, such as your high-level architecture, your design decisions, your core business rules. These should live in your most stable components, meaning they ideally have no or very few outbound dependencies and many inbound dependencies, many things depending on them. Of course, we also want for these rules and decisions, our business rules and such, to be flexible, and so we can achieve this by using the open-closed principle and the use of abstraction. Which brings us to the next principle, stable abstractions, which basically states that your components, your assemblies, your projects, should be as abstract as they are stable. So that is, stable components should be more abstract, unstable components should be more concrete. Assemblies that have many inbound dependencies should be more abstract, those with few dependencies should be concrete. We can graph the relationship between abstractness and stability as shown here. So in the top left, we have components that are maximally abstract. They have nothing in them except abstract classes and interfaces, but they have no other packages or classes in the system that depend on them. By definition, these are useless because they can't do anything. In the bottom right, we have the opposite. We have components that are very stable, so they have many dependencies upon them, but they're not abstract at all. And so this is also known as the zone of pain, because these components are difficult to change because of their incoming dependencies, but they can't be extended because of their lack of abstractness. A very common example of a component that would fall into this area would be a set of classes that represent a database schema. Database schemas tend to be very volatile, very concrete, and highly dependent upon, and this is one reason why schema updates are often so painful for our software applications. The next couple of principles are separation of concerns. Separation of concerns is more a general principle that applies both to components and packages, as well as to classes and methods. It's somewhat related to the single responsibility principle that applies to classes, in that if we have multiple responsibilities or concerns commingled together, it's best if we separate them. Now, there's a lot of different ways that we can separate them that vary depending on the context, and it could be anything from splitting out a new method or a new class, or even moving code into a new dependency. And finally, the dependency inversion principle is pretty much the object-oriented design principle that the stable dependencies and stable abstractions principles we just looked at derive from. It suggests that your dependencies should point toward abstractions, not concrete implementations. A related technique with a similar name to the dependency inversion is dependency injection, which is also typically related to the strategy design pattern, and we'll see these in action in just a few moments. So that's enough background for now. Let's go ahead and look at a demo. And forgive me, I'll probably need to shift things around in my monitor here again. But we're going to show a simple guestbook application. All right, so let's save that. Okay. All right, so we're going to run this first off. And we'll pull over our window. And so I have a very simple ASP.NET MVC4 application. It's for a guest book. And it looks something like this. You can see it's the default theme and everything. I've just modified the home page to let us sign in here. And so we'll come in with Steve at aspconf.net. We'll say something clever like first post. And you'll see it's showing the message down here. And then we'll have Javier come and reply with some witty response and add that, and you see it showed up. And down here, pull this over, I've got SMTP for dev running, which is listening on my SMTP port on localhost. And so one of the things that this application does, as you can see here, is that it will, if you leave your email address, it'll notify you of other postings for the next 24 hours. So this is a very clever social media site that I've created. And this is the email that was sent when Javier posted, was sent to me, letting me know about his witty response. Now if we look at the code for this, I basically have put all the code into my controller. And so on the initial index, all it's doing is grabbing a view model, talking to my data source here and getting all the entries and displaying them. And then when I do a post, what's going to happen is I'll check to see if the model state's valid and pass a message. But other than that, I'm doing a little bit of work here to set the date of this new entry, because that doesn't come in from the post. Figure out who I want to notify, which is everybody in the last 24 hours that isn't the current user. Just pull out their email addresses. And I'm going to loop through those email addresses right here, which isn't necessarily the best design, in terms of scalability. And I'm going to send them an email with each one to say that this response was had. And then finally, I'll save the message again to my DB context and update my model and return the view. And so that's what's working here today. So I have a couple of questions for anybody here in the audience. Let me just jump over to Jabber and say, what is wrong with this code? What would you change about this code? If you're not on Jabber, we're in this URL here in aspconf room 1, and we'll see what anybody says here. All right, so no separation of concern. Somebody even asked before I was coming here that not put so much logic in the controller. More separation of concerns, more too much code in the controller. All good stuff. Anything else? This is like a typical Ohio user group in terms of user participation or lack thereof. All right. So yeah, there's not a lot of separation of concerns. Some people are still joining because they just saw the URL. Email function should be pulled out. Great. Let's look at how testable this code is. Single responsibility principle, definitely. All right, so we'll jump back here. Let's look at our tests. So I have written some tests, which is good. Let me go find SMTP for dev again, and we're going to turn that off for now. So I'm just going to stop listening on the port, and we're going to run these tests. The first test is just checking the initial thing. So I like to write my tests so that they make sentences. So the home controller index should set the message and the initial view model. So that's my test, and here's what it does. Basically, it's going to reset my entire database, which if this were in production would nuke the entire production database. And then it resets it with some test data here. And then I'm going to verify when I call this that I do in fact have this test email that I'm inserting down here showing up in my resulting output. So if I run this test, that one works. This other one's failing, so let me run it real quick. And let's see why it's failing. So if we look at this, we can see that it's failing with an SMTP exception. It's unable to connect. So now let's come back to our thing here. Let's delete all our messages. We'll start listening. We'll run this test again. And now it passes, and we see, look, we just got a new test message. So I can run my tests, but they're not really unit tests at this point, because I'm having to actually set up, my database has to be there, and this SMTP server has to be here. So it's not ideal from that point in terms of the ability to test it. So let's jump back to the slideshow and talk a little bit about testability. Now, I tend to be a big fan of testability. I like unit testing. I think test-first design works very well in many cases. But I'm not going to tell you here that you need to always test drive all your code. But I will suggest, and I'll open this to argument, that testability correlates to loose coupling, separation of concerns, and maintainability. That is to say that even if you don't have any unit tests, if you have a testable code base, you're going to have these features. You're gonna get the benefits of loose coupling. You're going to have an architecture and a design that exhibits separation of concerns, and in general, your code is going to be more maintainable. The presence of actual unit tests simply proves whether or not your code is testable. And if your unit tests don't actually work as unit tests, and instead they're actually integration tests masquerading as unit tests, as mine are at the moment, then they're kind of disproving the testability. So let's look at how we can add some unit tests here. We've pretty much already done this. So we're jump past this, and let me talk to you real quick about SMTP for Dev, just so if you haven't seen it before. This is a free tool that you can grab from CodePlex. The URL's right here. So jump out there if you want that. It's handy. And let's just skip on to incremental improvement. Now, assuming that you have an existing solution that is causing you pain because of the way it's organized, there are incremental baby steps you can take to improve the situation. It depends on whether your problem is that you have too many projects, too few projects, or projects that are organized in the wrong way, which types of steps you're going to take. But the nice thing about this is this approach allows you to avoid having to do a complete reorganization of your code base, but still allows you to follow the Boy Scout rule and leave the code better than you found it. So if you have a single project with no separation of concerns, sort of like my guest book currently, you can start to separate responsibilities into different folders within the project. Eventually, you can move the classes from these folders into their own projects. But if you've not done this before and you're trying to figure out what kind of organization makes sense, using folders before projects is a good first step, because it doesn't require as much change to just push some classes around into different folders or different namespaces. On the other hand, if you're at the other side of the spectrum and you find you have too many projects in your solution, the simplest way to move forward there is to just start with a new blank solution and add in just those projects that you're actively working with for a given unit of deployment. Typically, I consider that unit of deployment to be an application. So generally, I've found that it's best to have one solution per unit of deployment, but remember that it's perfectly acceptable to share code and to share projects between these solutions. Now, the challenge that you run into, and the pushback that I hear from some people when you do this, is that when you make a breaking change, let's say you do a rename refactoring or something like that in one of your highly dependent upon projects, this may not result in that rename refactoring automatically occurring in one of your other front ends. So this would be a problem if it went undetected, but you should ideally have an automated build server that is going to catch this right away. So as soon as you check in, you're going to know, oh, right, that broke that other application. Even if you don't have an actual automated build server, which I could understand because there's not very many of them and they're really expensive. I'm kidding. There's a ton of them and a lot of them are free and easy. But even if you don't have one of those, you could easily write a script that verifies that all the solutions work with the latest code and run this whenever you feel the need to do so, without actually cluttering up Visual Studio with dozens of projects and slowing down every build of your IDE. And we'll look at how you could write such a script at the end of this talk. So now let's look at how we can kind of go down this path, and we're going to start refactoring into folders, but still keep everything in one project. And let's look over here in the Solution Explorer, and we'll see I've added a couple new folders. And 10 years ago, 12 years ago, when I was first learning about the whole N-tier application design, this was the way it was done, and I know some of you probably still do it this way. So we've got these two acronyms. We've got BLL and DAL. The DAL is the data access layer, and the data access layer in this case is where I've pushed my DB context. So DB context is sitting here. And then the business logic layer is where I expect to put all my business rules. So I'm going to take my controller and I'm going to change it so that the logic's not in the controller anymore. We'll go look at that. Instead, I'm going to create a service or a business logic class that does this work. And so the main work that we're doing here is recording an entry. And then we're going to go and list those entries to display. So I've got two calls basically. I've got a record entry and a list entries. And since neither one of these requires any state apart from the thing that was passed into it, I can make these static. Now, I'm not going to, if you're about to hit stop on this recording or leave this room, let me reassure you that I'm not proposing this is the best solution, but this is an interim slight improvement solution to what we had before we get to the good solution further on in this talk. So don't go off thinking this is the best practice way to do it. Now, if we look at this code, basically we've taken our code that was in our controller, pretty much verbatim, and we've copied and pasted it into this record entry. We've passed in the value it needs here. We've made it static because it doesn't need any other state. And then we did the same thing with the list entries. We just encapsulated that call to pull out the DB context items. All right, so now if we look at this business logic layer, though, we still have some issues with it. For instance, it's now talking about several responsibilities. It has to figure out who is supposed to get notified. It has to know details of how the DB context works in terms of the schema and the different types that are involved there in order to make this query happen. Then it also needs to worry about actually sending these emails, which isn't necessarily a business logic concern. It's more of a plumbing concern. So we can push this into someplace else as well. And then it has this other step of actually saving the entry. And in this case, I have to do multiple things. I have to set the date. I have to get it a new GUID for its ID, and then actually call this. So setting the date and specifying what the ID is, those are more data access concerns than business logic concerns. So ideally, I would push those in there. Yep, somebody needs to be on mute. Sorry about that. Now if we go back, let's see if I can mute this person.
Please, guy, turn off your mic.
Is that better? Alright, that seems better. Alright, so let's look at our tests again. I don't think they've changed much. You can see here's our initial test, still doing the same thing. Other tests still doing the same thing. We'll run them both. And although we've cleaned up our controller code significantly, our tests are still talking directly to the SMTP server. So we just got another test here. Go away. So we'll work on fixing that in a minute. But the problem there is that we're still tightly coupled. We still don't have any abstractions. And adding a bunch of statics didn't really make that any better. The other thing that we're doing in some places is we're still newing things up directly. So for instance, here we've got a new SMTP client. So I don't have a static call, but just the fact that I'm newing something up directly in my code is causing that same kind of tight coupling. And so it's sort of the new is glue rule that I blogged about a few months ago that you can try and keep in mind for that stuff. There's also nothing to prevent our UI layer from just totally bypassing the business logic layer. So if we look back at the home controller, you can see down here we're using our business layer, but up here we're still using the DB context directly. So we would like it ideally if we could enforce something that would make it so that the home controller or the UI layer didn't have as easy of a time of getting directly to our infrastructure code and bypassing our business logic. Lastly, if we look at our solution structure, which we'll do in just a second, let's just jump back to our slides for this part. All right, so the problems that we have here, some of these I just described, is that our tests are not really unit tests. They're still integration tests. They're still tightly coupled. We've got dependence on data and email infrastructure stuff. I just talked about the prevention here. Now let's talk about the solution structure. If we look at the folder structure, we can see that we have a lot of mixed concerns here. So we've got app start, which is server-side code, BLL is server-side code, content is client code, controllers and DAL are server-side, images are client, models are server, scripts are client, and views are kind of both. So there's a big mix of things here. Now we can't always avoid this, especially in ASP.NET MVC. We all expect that our controllers folder is going to be there and it's going to have code in it, but we don't want to make the situation worse if we can avoid it. So we don't want to clutter our project with a whole bunch of different folders all at the same level that all actually belong at different levels of abstraction in terms of our application design, as well as being at the same level and parallel to the actual user interface content of this solution. So the architecture that I want to discuss at this point that kind of applies the principles that I've introduced and fixes many of these problems is one that goes by several names. And I tend to refer to it as onion architecture because it's frequently depicted as like a cross-section of an onion with many concentric layers. If any of you have seen Shrek, you know that onions and ogres have layers. However, the ogre architecture name didn't get very much traction, so we're going with onion. However, before it was called the onion architecture, it was also called the ports and adapters architecture, and before that it was called the hexagonal architecture, which I think was the worst possible name. But that was based on the fact that the original author, Alistair Cockburn, had a picture in his white paper that used a hexagon for the main application core. And so thereafter he referred to it as the hexagonal architecture. But that was sort of arbitrary. So if we look at how this is designed, we take all of the core models of your business logic and your classes that model the problem domain and the interfaces and abstractions. We put those in the center of the application. And then we surround that with infrastructure and concrete implementations. And we make it so that these implementations depend on the core. And then likewise, we take the user interface, we put that outside and have it also depend on the core while having access to infrastructure. And we'll see that our tests will also live at that same level. So the tests are able to hit core directly, or they're able to test infrastructure when they need to for integration tests. So if we look at how this is often depicted, here's one example where in the center we have our domain entities, our model objects, things like that. We have different interfaces. So this one shows repository and service interfaces. And then around the outside is where we have our user interface, our infrastructure, our service calls, and any sort of tests that we're using for the system. If you like different colors, here's another example, basically showing the same kind of thing. Where in the middle we've got the domain model, around that we've got services, and then infrastructure, user interfaces are outside of there. So now let's take a look at how we can introduce some abstractions and invert dependencies in the folders still on this application. If we want to get rid of these BLL and DAL folders and move this stuff into a system that has proper dependencies all set up, the first thing we would do for folders is add a new core folder. So we'll just create a new folder, we'll call it core, and in here we might have a services folder, is what I typically call it. So we'll have services, and we can take our guestbook static guy and just put it into services, and maybe rename that to a guestbook service just so it's clear. And of course Visual Studio won't name this for me. Alright, and we can change this as well. And if we make this so it's not static, then we're getting to the point where we have the start of something that we could use. Now the next thing we would want to do is take some of this implementation logic here and refactor that out. And so we want to think about the different responsibilities that we have and create abstractions for those. So the core responsibilities that we have here are that we need some way to get a list of people that we want to notify, maybe be able to pass in some kind of filter. We need to be able to notify them. And so this whole loop is all about just sending notifications. And then we need a way to actually persist one of these entries. So if we create a couple of interfaces for that. They would look something like this. And these would go inside of an interfaces folder. So we can go over here and we'll add another folder for interfaces. And we'll add a new item, which will be an interface. Like iGuestBook entry repository. And then this will look something like this. Now I've got both of them here, so we'll leave the this other one here for now just to save you time. We'll introduce a namespace that we need, and now we're good. So now I've got this notion of a repository where I can add entries or list them, and I can pass in this func of guestbook entry bool. So that's going to be basically a lambda expression that filters out my list. And then I can also send notifications. So if we come back to the service and we want it to implement those, we can just create a couple of fields, and we can have an iGuestBook entry repository here. And it's going to want a namespace. And you can get the just control dot will bring that up if you don't know that shortcut in Visual Studio. And then private read only I send notifications, notification sender, right? So now if I want to get these emails to notify, instead of talking to DB context directly, I can talk to this abstraction, which is not a static reference. And I can say guestbook repository dot list, and at this point I just need a filter, and that filter is going to basically be something like this and this, right? And then I can still select that, and that replaces all of this. And then I just want to notify somebody when this happens, and I don't really care how that's done. So we'll say I've got this notification sender, and it has some notify thing, and it just takes an entry, so I can just pass my entry, and then it'll figure out how to do it. So I don't need that anymore. In fact, at that point, the emails to notify here isn't even necessary, so I could just get rid of all this as well. And then the last part is to save it. And that's where, again, I can use the repository. And I can just add one of these things and pass in my entry. And this can go away. All right, so now I've got this service, I spelled wrong, that does very little. And if we clean up all the code it doesn't need anymore, let's assume that when I implement notification sender, it'll actually do all this work in it. We could pull all this out and pull all this out, and we'll have something that basically does two things. So let's show what that looks like. Now this definitely has a much better separation of concerns, right? So there's nothing going on here. We could also change this one to finish the job. We can say this one's just using the repository. It needs to not be static. And so it'll return all with that. So now our service is much simpler. If we wanted to write a test for this, we would just test to see whether or not we actually made a call to this and made a call to that. Now, you'll note that there's no actual way for this to work right now because I don't have any way to set these two fields. So the next step would be to apply the strategy pattern and create a constructor where I could pass these in. So that would look something like this, and I would just take my repository and pass it in, and then assign it here. And do the same thing with the other one. So we pass this in. And do the same assignment. All right, and now that works. Now if I want to use this, I can go back out to my controller, which is now complaining, and do the same kind of thing in here, where let's say I want to use that guestbook service instead of this DB context. Well, I can say right here var my service equals a new guestbook service, and it's going to need a namespace, and then it's going to complain it doesn't have these things it needs. Right? It needs a guestbook entry repository, and I haven't implemented those here, but when I did, I would new up a guestbook repository here and pass those dependencies into it right here. So I'm not going to bore you by typing all that in, but once that was there, let's do that. Then I would just call here my service.listEntries, and we would no longer be talking to the data access layer as we refactor this. So let me do a quick update on my source code and show you what this will look like after you complete this refactoring a little bit more. Alright, so now let's look at home controller, and you can see that the exact thing I was just talking about has been done. We've got this field for iGuestbook service. We've passed in the implementation. This is the strategy pattern right here. Now I'm going to, in the constructor, go ahead and pass all these things in. So my home controller's default constructor delegates to the one that takes in parameters, which is the one up here, and it passes it in a new guestbook service. Now guestbook service, we saw a second ago, actually takes two parameters itself. It needs this repository and it needs the notification service. And it turns out the notification service also needs the repository, so it can do that call, as well as the ability to send emails. And so once we have all that in place, we can come down here, and in our persistence method of our controller, we can just call record entry as well as list entries here, and have all of that done in such a way that we aren't newing up anything except for a value object, which is this view model. So at that point, we're getting to the stage where we can actually write some unit tests that decouple these things, because we've got some abstractions. We'll show, before we get to that point, we'll show how to pull these into separate assemblies. And now let's go look at that actual service now that we're done with it. Here's what the code I just typed in, cleaned up a bit, and what's passed into it, and what it does is just notify everybody and add the item. If we want to see how that's actually done, we can come down in here and we can see we've got the repository has an add method that just is exactly the code that we had before in our static method, but it's been copy and pasted here. And the list method as well is pretty much the same thing. It's just got this check for if the filter is not present. And then the message sender, this literally just sends one message, so it knows how to send one email. The notification service is actually inside our core because it doesn't have any infrastructure concerns. It's all business logic. And so we want to be able to test this without having to deal with emails. And so that's why this service is living in core while the actual thing that talks to the email server is down here. So in our notification service, you can see that we're calling that guestbook repository list. We're passing in our lambda expression to do the filtering, and then we're just for eaching through. But instead of doing all the email work right in line, we're just passing in the email address and the message body to our send notification email service. So that means we can test this one in isolation as well, because we could just pass it in the message sender and the repository, and then we could test whether or not this works in isolation. Now this is still a little bit of lack of separation of concerns because it's doing two things here. It's looping through emails and it's filtering. So we'll see in a minute how we can actually pull this logic out into something separate. Alright, so let me see if there's any questions that are waiting right now. Doesn't look like anything in particular. Ogre architecture is good. Alright, we could call it parfait. Good job. Awesome. Alright, we're doing well. We've got time. So let's jump back to our slides. Alright, so let's analyze what we've got now. I just walked you through the code. We've got unit tests that can work. I'll actually, let me actually jump back and show those, because there was something important I missed. So in our unit test now, let's check out what we're doing. We can, at this point, stop with the resetting of data and actually write some implementation code that'll do this, because we now have the ability to pass things into our home controller. So if we look at this and we see that it has some dependencies, we can pass in our own implementation of a guestbook service that makes this work. So let me pull the next one of those out. our method that is actually on the controller that's doing the updates, we've modified. So you can see here the new home controller, we're passing in a guestbook service. Now our guestbook service doesn't really do anything that's infrastructure like, so we don't have to fake it out. But we're going to pass it in a fake guestbook repository and an email sender, which is actually our fake email sender. So let's look at how we implemented those. They're actually right here inside of my test class. And so I have two classes. The fake email sender just has a public string that says, here's the email address of the last message that was sent to this email sender. And it starts off blank. And then it just, anytime you call, send an email, it just sets that. And then our guestbook entry is similar. It just says, has save ever been called? And it starts off false, and it'll flip it to true. Now you can use a mock framework, and we'll see how that works in just a moment, to do this a little bit easier without having to hand code these fake objects. But even if you aren't doing that kind of thing, it's very easy to write these up yourself and to give them just exactly the types of properties that you need in order to probe them after you run your test to make sure that they did what you expected. And then finally, also on the guest entry repository, the fake version, we're going to implement this this list method, so it always returns this one entry that has the test email and the test message. And that will let us now run this with all this fake stuff, pass in a posted model, which is a new, different one. So we've got the initial one here that says test message. We've got a new one that has an email address of new email and a new test message. And we're going to expect when we're done that this thing is going to have sent an email, and it should send the email, because of our business rules, it should send an email to test email letting it know that this new entry was added to the system. And it should also persist this entry, which means that it's true that our repository was save called should be true. And we can now run this one all by itself. And you can see it passes. And it does not actually send any emails or have any kind of infrastructure concerns. All right. So now, let's jump back to slides. Wherever they might be. There we go. And so, okay, now we've got unit tests that work. And by unit tests, we mean tests that don't rely on infrastructure. However, we still have nothing to prevent the improper referencing of classes. It's very easy for our UI code to call data access layer code directly and bypass the business logic. And of course, everything is still in the same project, so we've got mixing of content and code folders. So let's look now at how we can refactor this into projects. We'll do this pretty quickly. The short version is that you can just come up here and right click and say add new project. These are always going to be just class libraries, so call it core. That one happens to exist already because I've done this before. And then the other one I would suggest you call infrastructure, which I'm sure also exists. Alright, so let me update to the next version so I can show those two. Bam. Reload all this. And so here's my core project that I would have just added, and my infrastructure project. And back to the UI, you can see I've pulled those out of here. So my folder structure in my MVC project has gotten a little bit cleaner. My controller code is still pretty much as it was before, and it's still calling, straight into that service. But now it's using the core.interfaces and the core.services namespaces, as well as a reference to infrastructure. And so in core now I've pulled out my model, which we haven't actually seen yet, but here's what it looks like. I've got my email address, my message, a date created, and a GUID ID. I've got my interfaces, which we've looked at a few of these, and my services, which we also just looked at. And then down in infrastructure, I've still got my data layer, my email sender, and my guestbook repository. So let's build this and fix a couple things. So here, we can see this is still relying on infrastructure. This is in our test. Our tests don't need to talk about infrastructure anymore, so we can get rid of that. Our reset data, we don't need that anymore. In fact, our whole reset data concept is gone now. And at this point, we can actually build our test, and it'll work. And we can go and look now at the home controller itself and see that it's talking about infrastructure here. This is a warning sign, right? So now that we've broken these things out into their own projects, their own namespaces, it's much easier for us to detect when our concerns are jumping past the abstractions that they should be using. So, anytime you see this using infrastructure in your UI layer, this is going to be a red flag that you should look at this and investigate. So if we get rid of this, this is going to identify where the problem is, and we'll see now all kinds of problems that we can't quite fix yet. So we're going to leave that there. But the one that I'm most concerned with is right here, this DB context. And so for this one, I'm just going to use my guestbook service.list entries, and that can be null. And doesn't need that. And now we should be able to build, and everything should still work. So it's good to run the app every now and then to actually prove to ourselves that it works. So let's try that. See if I've completely broken everything. Let's make sure our SMTP guy is running here. Clear all these out. And there's one. I'm not as witty the second time around. There's two. And there's some issue here. Oh, that's because I didn't actually make it an email address. I should be as witty. Alright, but it is actually get in here and try and send the email. It just failed when it tried to actually use 2 as a, or 1 as a valid email address. Alright, so that seems to be working. So we've broken this out into projects. And so you see, these are my standard project organizational folders. I've got a core project. It has interfaces, models, and services. I've got an infrastructure project. Eventually, this is going to get broken up into some folders. There's probably going to be a data folder or repository implementation folder or something like that, and some other folders related to whatever the infrastructure might be for this particular project. Let's look at the results now. We've basically gone from a single project solution with a very simple project to one that is now broken out following sort of the hexagonal onion architecture approach. And so we now have testable code. We've got some separation of concerns. Things are not co-mingled together. We've got loose coupling because we're able to inject in a different implementation at test time or at runtime from the one that was originally designed. We've got minimal logic inside the user interface layer. And so as a result of all this, we've got a pretty solid foundation for writing a maintainable application. So there's a few more things we can do to improve this. One of the things I mentioned that we can do is add some automation. And so in pretty much every project that I work on, one of the first things I do is I try and set up a one-click build, one-click test set of scripts. So let's look at that next. We'll actually pull up the folder that we're in, which might be that one. Hey, it is. Alright, so here's our folder that we've been using. And we just update Mercurial to the correct version. And magically, a few more things just appeared. And so I've got 3 scripts here. I've got a build.bat, I've got a build.proj, and I've got a click to build. Let's look at the batch files first. So we'll go in here, and build.bat is essentially just going to call into MS-build at wherever path it may use, and call build.proj with a target file, a target parameter. Click to build is similar. It's just going to call build.bat, which we just saw, and it's going to pass in the release build target, and then it's going to pause. That just lets the DOS command prompt sit there and wait for you to press a key before it goes away. Now the real magic is in this build.proj, and this is simply a MS-build file, and it's an XML format. If you haven't looked at MS-build, people used to talk about it a lot when .NET first came out, but these days it's not as sexy as some of the other technologies out there. But it still has a great deal of usefulness when you're automating some of these things for your project. So in this case, this build.proj has a couple of different targets that are defined. And so you can see there's one here called debug build. There's another one called build and test, and another one called release build. And you can see that debug build, the next one, build and test, depends on it. And likewise, build and test is a requirement for a release build. So when we call our click to build method, it's going to chain these together. It's going to run the debug build, make sure that that is successful, then it's going to run all the tests, make sure those all succeed, and then it's finally going to build everything in release mode so that we are ready to deploy. And so every time we double click on this, we have a deployable application that's ready to go. Now we parameterize this a little bit, so the project name, guestbookMVC4, is here, and then you'll see that gets used all throughout this place to make the code a little bit more reusable. Likewise, the MS test path we reuse just because it'll vary from machine to machine and version to version, so we pull that out into a variable as well. If you wanted to do the option where you have a solution that has 100 different projects in it, and you want to be able to work on just the ones that relate to your application, but still be able to run a build that verifies that everything still works, you can do that very easily with one of these scripts. And in fact, since every project file is in fact an MS build file, it's very easy to do that. You can also just refer to any solution file and run that as a build through MS build. So here you see I'm just running this project with, by calling it solution. If I had another solution that was everything, it would be very easy for me to do something like this and say everything build, and have something in here that was like everything solution. And then I could just write a batch file that will run the everything build anytime I'm ready to do a real check-in without having to run that every time in Visual Studio. Alright, so let's actually run this and see what it does. So I don't remember what state we left our tests in, but we'll find out in a second. So there's our debug build. And there's our tests running right now. And they must have passed because now we're doing our release build. And it says our build succeeded. Press any key to continue. Alright, we can prove that these are actually doing their thing if we jump back in here and go look at one of our tests. And jump down to the bottom here. And we'll just assert fail for no good reason. We don't even have to build now. I saved it, but I didn't build. But I can jump back to here, run my click to build again, and it should very quickly realize that these tests aren't going to work. And so it runs the test right now, bam, and it fails. So my build fails, my test results tell me that one failed, one passed, and I can open up this, since I'm using MS Test, I've got this TRX test results file that I can go open up if I want to see the details. Depending on if you're using NUnit or XUnit or MS Test, you'll have different ways of seeing that output. But it does also show it to me here, line by line with each test. All right. Oh, this one. All right, so now let's talk about how we could add some more tests to this system as the final thing we want to do. Because in the beginning, we didn't have very good tests. Because the system was difficult to test, it required a lot of infrastructure, and because testing was difficult, we didn't test very much. So let's see what happens if we make some updates to the system. Alright, so now we've got our tests. Let's look at them. We've got core, we've got model, we've got services. We've pulled out some things here in this next update that I want to call your attention to before I show you the tests. So in my service, I've got this notification policy. And the notification policy is defining the members to notify of a new entry. And so this is how I'm going to pull out that business logic that was sitting inside of the notification service and have that be a standalone thing that I can inject separately. Now if we look at the implementation for this, we can find all references. Here's our notification policy. We'll see it's right here. And it says what we've been using all along. Here's our Lambda. And now we can write a test for this. And so we can come into our test project and say our notification members to notify. And basically our two rules for our notifications are that we want to make sure it does not include the person that actually made the last post, because they don't want to get an email to themselves saying, hey, that you just sent an email. So we're going to say, here's my new poster email, and that's my test email. And I'm going to create my test data here. These are my entries, one of which is going to be that one, and that's number 1, and then 2 other email addresses. And I'm going to just run that policy through here. And so I can just call a where clause with some link and pull in that lambda and get a result. And I'm expecting that result to only have the latter 2 items in it. And then it certainly should not have the one that's number 1, right? So we can run this test, and I expect it to pass. And it looks like it does. But now we want to write another test. We want to write a test that verifies our date logic, because we've been saying all along that we only want to show the last 24 hours worth of these things. So we should exclude any entries older than 1 day, and we don't care about the email anymore, but we do care about the date created. So we'll just leave that the way it was. Date created equals something, and in this case we're going to say it's a new date time, and actually since everything's keying off datetime now, we'll say it's datetime.now, and that one should show, right? Then this one here, number 2, we'll say is datetime, or date created equals datetime.now.add days. It's a day ago. Add minutes, or milliseconds, probably work, but say minutes, 1. So this is a day ago plus a minute, so that should also show. And then this last one will make it be a little older, so we'll say it's date created is equal to datetime.now.add days minus 2. And then we're going to get our list in our result, and just like before, we're expecting 2 of these to come back, right? So the one that was now should come back, the one that was not quite a day ago should come back. That's our edge case. And it should be false that we have any of them that have the number 3. That one shouldn't be there. All right? This looks good to everybody, right? I could go check Jabber for an answer, but we'll just keep going in the interest of time. So now we're going to run this test. Oh, it failed. I'm so surprised. What happened here? So we've got this test failure now that says we should have excluded things older than a day, but we didn't. And our is false failed. So we actually had this number 3 in there. So what's going on here? Well, let's go look back at our policy. In our policy, we're saying, give me all the entries where the date created is less than datetime.now.add days 1. That sounded good when we wrote the code to begin with, but now that appears to mean that any date created that's less than tomorrow is going to get returned, which will probably be everything. So I think I can fix this by saying that the date created should be more recent than add days minus 1. So we'll flip the sign and fix that. And save this. And let's jump back and run our tests. Now they both fail, even better. Now this first one has got an issue because the date created on all these is starting out as min date. So let's just make these datetime.now. We'll just tack that onto each one. And run them again. Alright, so that one's good. Now what's going on here? Let's just add a debug point here. And we'll debug into this test. And I can't actually hit the F keys because it'll mess up Camtasia. So I'll just step over. And let's look at our result. So our result has only 1 item in it, and the 1 item that it kept is another. So it was okay with add days minus 1, add minutes, but it's not keeping... Oh,
it's not going to send to yourself.
Yeah, thanks. I just realized that. It's still got that test email one in there, so it's still running the same rule that we had in the upper one. So we don't want that test email.
Hey, Daniel.
This one. So we'll just make this be...
Can you mute everybody, please?
Some other email not involved in this test at domain.com. There we go. Turn this off. Run this one more time. Yay, okay, it's green. Thank you for the help. All right, so now the point of that is that we've shown that because we've separated these concerns out, we've managed to pull what started out as a very complex controller method with a lot of logic all commingled together into some separate pieces, even getting so far as to have our lambda expression expressed as a separate class with a single implementation here. And this is our notification policy. And we might have multiple different things in here. So maybe we notify admins one way and subscribers another way and what have you. So this, eventually you could imagine this notification policy being a little more substantial and having several of these. But the point is that we've pulled that exact logic of determining who gets notified into its own separate class with an interface, so it's abstracted, that allows us to test it in isolation. And because we're able to test that in isolation, we're able to catch bugs that otherwise manage to elude us. And I don't know, unless somebody on Jabber pointed it out and I missed it, nobody throughout this whole course had anything to say about that logic error that was on the screen, several times in the last hour. All right. So at this point, I am ready to wrap things up. Let me do one last update of the code, make sure it's our click to build. Make sure there's nothing else I need to talk about. Okay, reload everything. Looks good. Jump back to slides. All right, so we added some tests, fixed things up. Let me talk about these references real quick. So if you're interested in any of the topics that were related in this talk, we've got separation of concerns, hexagonal architecture, onion architecture, even more onion architecture, and also my discussion of how using new in your system is gluing your implementation to other concrete implementations. And then I'm an author on Pluralsight. These are a couple of the courses that I've published, either all by myself or with some others. The Design Patterns Library is a bunch of different people. But I encourage you to check these out. You can get a free trial from their website, so you don't have to subscribe to get access to these, at least initially. And let me jump to the Q&A part of this, and I'll jump onto Jabber as well as Live Meeting and see what questions have come up and cover any of those. So here's Jabber. Unit tests have dependencies on externals. Yes, they do. I haven't deleted those yet, but they don't need to anymore. Use DI to remove those. I could do that. Yes, good idea.
You got a good question in Jabber, probably.
Jump to the end. Who do you feel is responsible for creating view models in an MVC project, the controllers or the service layer? And would you recommend separating out controllers into a separate assembly? I would not tend to put controllers in a separate assembly because the MVC project is really just a place to store some static content and those controllers. There's not much else to it. I mean, you've got views, but I'm a fan of having really dumb views, so I don't expect for the views to have much logic in them. So the question, let's see, I think controllers work is done in the view model itself. There shouldn't be any work looking at this one. I wouldn't expect there to be any work done in a view model to speak of. My view models are really just value objects that hold data. If we look at the view model here, for instance, I've kept that in my UI, but I don't think I ever showed it. There's no logic inside a view model. The view model is really just a place to hold stuff that is going to get shown on the view. So there's no need for tests of your view model if you follow this approach. Because you're really just testing that C#'s properties work, which isn't that interesting. More onion architecture appears to have been removed. The first link, assuming it works, will link to the other ones, so that shouldn't be too big of an issue. View model is just a bucket for data. Yes. Who creates the view model? Okay. So the question is, should the view model get created by the business service or the controller? There's a few different ways you can do this. Jimmy Bogard, who's presented here and maybe presenting here this year, I'm not sure, when it was MVCConf, has a great talk on putting your controllers on a diet. And I tend to follow in any real application sort of the approach that he has, where a lot of the work of the controller gets done by handlers or by things that get attached to the controller through attributes. He has a talk, like I said, that's on putting your controllers on a diet that I'm not sure is still available, but it was on the old MVCConf website. I think it just went down recently, but it shows how to do that, and you end up with a controller that's like literally one line of code. Your controller says return view, and here's the view model, and that view model actually got set in a separate handler. I like to do public view model, domain model, construct things. What's your opinion on that? That creates a dependency from the view model to the domain model, which isn't necessarily bad, but it could be. What I typically like to do is instead of that, I will sometimes have AutoMapper used to pull in my view model from the models if there's a tight correlation between them. So I'll tend to use AutoMapper instead. And anyone that's not familiar with that, it's on Codeplex. It's free. It's Jimmy Bogart's tool, actually. So automapper.codeplex.com. It's actually on GitHub now, apparently. But this is a really awesome tool if you're having to map things from entities to domain objects to view models where a lot of the properties are the same. Let's see. How do you set up builds and continuous integration on TFS? I haven't done it in a while, but there is, of course, the whole build server system on TFS, so that would be the obvious way. Alternately, you can just write your own scripts, like I showed. And I have had good success with Cruise Control as well as with TeamCity, both of which are free. So you can get cruisecontrol.net, and that works pretty easily. You can get TeamCity, which is free for most small or open source projects, and works really well and has a nice web user interface. Data validation, would you implement this in services, not data annotations? If it's business logic, I would try and put it in my core services. I would not try and put it in infrastructure. If it's tightly coupled to my database schema and not necessarily related to business logic, but it's just like an implementation detail of how my database works, then I might put that inside infrastructure. And so if I'm using an ORM tool that's mapping from my database schema to my logic, that would be inside my infrastructure as well. So any kind of entity framework or Hibernate or nhibernate or what have you, all that stuff would belong in my infrastructure project, and those would have any of that data validation that's specifically related to the schema. But again, anything that's data validation that's a business rule, like if the user specifies a zip code, they must also specify a city or something like that. That would be inside my model, either directly inside the model classes or more likely in a separate class so that there'd be some separation of concerns there. How do you do something like a remote model validation in this structure? If it doesn't belong on the model property, can it be dynamically added somehow at controller init or runtime? So again, I would say validation, there's different levels and types of validation. Validation's a cross-cutting concern, but validation also needs to be context specific. So it's generally, in my experience, naive to think that you can say that an object is valid. Typically, it's better for you to say that an object is valid for a particular context. So, for instance, if you're trying to save a customer type, there's certain things that need to be present in order for you to create a new one. There's different things that might have to be present in order for you to save it or for you to change it from one state to another. If you think about like an article on a website, the things that you need for an article to be saved in draft aren't necessarily the same things that you need to be able to save it when you're submitting it to editing, and they're not the same as what the editor needs to save to make it be in the published state. So essentially your validation needs to be state transition specific, and that makes your validation almost a service itself sometimes, depending on how complex your domain is. If it's really, really simple stuff, then there's no need to make it more complex than it needs to be. You can just throw an isValid on there and check it. But generally that doesn't deal with complexity well. So eventually you end up pulling it out into something a little more flexible. All right, more onion is well formed. It should link to there. Okay, thank you. That's good. What about complex validation logic in your view models? Why would you have any complex validation logic in your view models? Jim Bogard, this is also a good talk. I saw this at Codeplex. It's not the same one as he did here, but it's also good. Do you use cruise control TeamCity instead of TFS or with TFS? I don't generally use TFS if I can help it. You saw for source control I'm using Mercurial. I prefer distributed version control if I have a choice in the matter. So the whole with TFS at all is for me sort of moot because I don't tend to use it. But if I did, the answer to that would probably depend on the organization I was doing the work for, because they're the one that would be dictating that I'm using TFS at all. And so if they said I had to use TFS for my builds, then that's what I would do. But otherwise, by default, I would probably just use TeamCity because it's easy and works. These are build servers. They don't have source control built in, so you can use TFS if you don't want to use it, and you can use one of those mentioned. Right, good. Jenkins is another one. I have not used it, but I've heard it's good. And App Harbor is quite neat and free. Yes, it's not exactly the same thing, but that gets you even a step better. With App Harbor, you get continuous deployment, not just continuous integration. So I have not used App Harbor much, but aspConf is using it right now, and it seems to work. So it seems that if you put your controllers on a diet, you force your business service layer to become dependent on your view models. How so? Is it because they're going to have to be the ones creating the view models? In the talk that Jimmy Bogard shows, the actual creation of the view models still lives in the MVC project. I don't think I have any sample code here that will show that, unfortunately. But essentially, there's a handler that gets attached to controllers that have a particular signature, and that handler goes ahead and does the view model stuff for you. But it does so in the UI layer, so it's not something that's done in excuse me, it's not done in the core or in the business layer. So thank you, Jordan Hammond. Here's the Vidler link to the put your controllers on a diet. How do you feel about WCF service contracts and decorating the interface in core with the service contract attribute? So let's look at core again real quick. Now again, this is a very trivial application. It does not talk to any services, doesn't do a whole lot with entity framework. I actually did I was careful not to show you DB context during the talk, but my DB context actually looks like this. It's literally just an in-memory collection of entities. So you could imagine that this was really entity framework or in Hibernate or whatever, but it doesn't have to be, and it wasn't important to the talk that it was. But because of that, if we look at our model and we look at our guestbook entry, I'm using component model data annotations, but I'm not using any of the entity framework ones. And if we look at our references, you can see I don't have entity framework referenced in here at all, nor do I have any of the WCF service type references. And I'd like to keep that as clean as possible, because then there's no chance of an infrastructure concern sneaking into my core. As soon as I come in here and I say add a reference, and we're going to go to, what is it, Microsoft Entity or System Entity? It's System. There we go. System Data Entity. As soon as we add System Data Entity here, there's really nothing that would prevent somebody from sneaking in, let's say down here to a service. They go and they add a new item for a new ADO.NET model, and just create an empty one. And now all of a sudden I've got this infrastructure concern baked into my core because I have that reference available. Likewise, to answer the question, if I've got WCF stuff in here, there's nothing to prevent more WCF infrastructure plumbing code from showing up in here. So what I try to do is keep the references of core as small as possible. And so I know I don't need system data entity, so I can delete that. If that causes problems when I go to build, I know that something's wrong and something was here that shouldn't have been. So all these things that are dying with model, I know that's a problem. I should get rid of that. And I can just come through here periodically and delete any of these that I don't think I need, and try and keep that as clean as I possibly can. And that's what will make sure that core remains dependency free. So your service interface wouldn't be part of core. No, I would typically put the service interface. Let me think about that. I have had issues with WCF and with other things like End Service Bus, where you have to have a common interface, and that common interface needs to also implement some other pre-existing interface. For instance, within Service Bus, there's an iMessage that you have to use, and with WCF, I think there's some similar stuff. So if I could avoid it, I would not put my service interface in core. I haven't done anything that used WCF, honestly, in like the last year or two. So my answer to you, Chief 7, would be that I would avoid it if I could, but if I couldn't, then I'd bite the bullet and put it in there. And I would just try and be careful not to let any other WCF concerns get in there. Yeah, okay, Daniel, I agree with that. Yeah, you can put things like required on the view model to make it so that MVC is going to create the validation for you on the client side. I think that's perfectly fine. That's the challenge with that is mapping that to any other validation you have and keeping those in sync. And I don't necessarily have the best answer for that. That's been a challenge that I've run into. So I do this. I do add like the required attribute and other MVC validation attributes. I do also add those attributes to my actual model class, but then I don't necessarily. If we look here again, my guestbook entry has required on it, but I don't necessarily push that out to the view model if I can help it. So in my view model here, in this case, I am just passing the model straight to the view, but frequently I wouldn't do that. Like I would restrict this to only the things the view cared about. And in this case, the view is showing basically the whole guestbook entry type. But if guestbook entry was this big thing, then I would have public string guestbook entry email here, and public string guestbook entry message. And then the validation on these would be an implementation detail of the view model. So I would be fine to put required on this and required on this. And then the mapping of these to a guestbook entry would take place somewhere else. That would take place either in the controller or it would take place in a service that knew about these. But again, I only would bother to do this if this type was very large and complex and the view model didn't care about that complexity. So I would try and make the view model as simple as possible and not have extra stuff in it that it didn't need. And that's where AutoMapper comes in again too, because this is the homepage view model. But again, if this guestbook entry was very complex, I could certainly see having a public class guestbook entry view model that would have those things I just showed, right? So it would have the email and the message, pretend that's real code. And then up here, I could just have this use the other view model. And so the view models would be sort of chained together, and getting from this view model to the actual guestbook entry model here would be a simple matter of AutoMapper. And it would just happen in AutoMapper's config one time. And it would do that for me, so I wouldn't have to worry about it. All right. Room's got to roll in the next 5 minutes. All right, good. I'm pretty much done. So, you ever think it's iValidatable when you do? I do not use iValidatable. I'm not saying I wouldn't use it, but I haven't used it. You can put IOC resolvers in each project. I will typically put the IOC resolution in my UI. I used to pull that into a separate project, but I found that was overkill. So I just put the IOC at the highest level. Is core and infrastructure a convention of yours, or is it a published best practice? I didn't necessarily invent it. It's one that I actually learned pretty much from Jeffrey Palermo, the guy that wrote the Onion architecture stuff. He uses it. He has used some other things like a dependency resolution project. Like I just mentioned, I stopped using that because it wasn't really adding value. But definitely core and infrastructure are standards I've used for the last several years, like really the last 4 years, quite effectively. And I've written about them and others have written about them, but I don't know that it's like in a book or something. Where would you register dependency? Okay, in the web project. And yes, that would mean the web project needs a reference to infrastructure. Yes. If you use something like MEF, I believe you can get away from that because you can just drop the dependencies into a folder and MEF can pick them up out of that folder. You could do that also with other IOC containers and avoid having that reference. I have not done that, but if you really wanted to be hardcore about not having that reference to infrastructure, you could do it that way, and then when the project starts up, it would just pull things out of that folder. You'd still have to make sure the updated DLLs were in that folder, but you could do that without having an actual project reference. All right, so I think I need to be done because other people need to use this room. Name of the book I mentioned. It is Principles, actually it is Agile, Principles, Patterns, and Practices in C#. And grab it on Amazon. So thank you everybody, I hope you enjoyed this, and I'm going to make way for the next presenter.